Want to give a quick announcement before we start. Today is the deadline for applying for LA faculty applications. So if you have any questions, you can email me or you can email Hagit. But everything is online and on the emails that we've been sending. So remember, today is the deadline for applying. And I know like a few of you have already applied, so that's great. And today I have the pleasure to introduce Michael Dorsey, and he's going to be talking about the interconnection between humanities and science. Thanks.
Thank you. Well, thank you all for coming. It's a great pleasure to be here, an honor to be here, and I'm very anxious to present this talk to you today about the conjunction of scientific and humanist thinking, because I got a great deal of feedback from my colleagues in the humanities, but I think it's equally important to get the perspective of scientists and to understand what needs to be said, what needs to be elaborated, and what's fairly obvious. I know as I go through the talk today, there will be some things that are all too obvious to you and others that perhaps are not. And a presentation like this is very useful to me in terms of learning where the emphasis should be. To start, I want to stress that I do understand that the term science and the term humanities are somewhat each is somewhat of a misnomer. There isn't science, there isn't a humanities that we can look at and understand and see the structure and the elements that make it up. Rather, they're terms that we use for general perceptions. That's not to say they're ineffective. We do the same thing with a term like religion. Religion is the civilizing force that differentiates us from all other organisms. Religion is the opiate of the masses. Religion is this. There is no religion, but per se, there are different religions. But we understand what that means. It's a way of thinking. It's an orientation. And when we use the term, it gives us a sense of the perspective of everything that's going to follow. And that's how I'm using the concept of science and the humanities. The point of my talk and the larger study on which this is based is that we always think, whether we identify ourselves as humanists or as scientists, we always consider a range of attitudes, and science always enters into our activities as humanists. The elements of the humanities are always part of what scientists are thinking about. It's not necessary to go any further than the FIU biology department for an example with our colleague, Professor Emeritus David Lee, who looks at flowers and sees them as a botanist, but sees them for the aesthetic power as well. And the point that I'm making with this encouragement for underscoring the tension, the complementarity of science and humanities, is that when I'm looking at a flower and I understand not simply the botanical makeup, but the pleasure that human beings take from looking at the colors and the shape and the arrangement. When I can understand both, I understand better whatever my specific topic is going to be. It's something that I think we always do, and I'm not trying to teach anyone, any scientist, how to think like a humanist, or any humanist to think like a scientist. Rather, I think it is always naturally part of our way of perceiving, and our advantage comes when we become more aware of these multiple elements. The title of the talk, beginning with a quotation from Mark Twain's Huckleberry Finn, "Come back to the raft, Huck, honey," was a way for me to encapsulate that continuing presence of the both and presence of science and humanities. It's from a
Refresh
scene.
my memory, who said that to Huck?
Jim, the runaway slave. Jim is on this. Jim and Huck are traveling down the Mississippi on a raft. They're going the wrong way. Jim is trying to get away away from the slave territories, but the current of the Mississippi is taking them in the wrong direction. But they're traveling on the raft, and one evening, while Jim is sleeping, Huck decides that he'll play a trick on Jim. He slips over the side of the raft and clings to the side of the raft, and then when Jim wakes up, Huck isn't there. And he goes, he's very disturbed, very concerned, and he says out loud, "Come back to the raft, Huck, honey." And Huck is, for a moment, deeply hurt at himself and his willingness to put his friend through so much concern and so much care. It's a moment of revelation for Huck, but it's also, for me, it captures that idea of a presence that we're not necessarily aware of, but is always there. The humanities and science as we're looking at the world. This isn't a new way of understanding. From the time of Miletus of Thales, 2 millennia ago, individuals thought about the world. Miletus was a mathematician and a philosopher, and he saw the two not as distinct disciplines, but joined together and complementing one another. From Roman, through the Roman period, through the Middle Ages, into the Renaissance, with intellectuals like Lucretius, Roger Bacon, Leonardo da Vinci. I'm not very good at PowerPoint. The only reason I even have slides is that everyone else has them. So I thought, well, goddamn it, I better have something up on the
That's
screen.
not in science as well.
So this is a very rudimentary presentation, and I ask your indulgence in that regard. But you can see there's a change. People thought and discovered a great deal about the world around them through an openness to ideas, by avoiding segmented thinking. Near the end of the Renaissance, however, this disposition towards multiplicity, towards complexity, began to change, and there began to be a greater emphasis on one perspective or another. Scientists like Galileo, Copernicus, Sir Isaac Newton, that's not him, I'm sorry. Made tremendous discoveries, but in doing so, they began to alter the way people conceived of the universe and the way that they balanced the physical and the metaphysical in understanding the world. By the time of the Enlightenment, and in the 18th century, philosophers like Voltaire, Jeremy Bentham, Immanuel Kant were moving further and further away from science and from science, just as Newton and Copernicus and Galileo had moved from the humanist perspective. By the time you get to the 19th century, Jean-Baptiste Lamarck, Alfred Russel Wallace, Charles Darwin, and philosophers like Schopenhauer, Nietzsche, and Hegel. There it is. We're going further and further away. It became in intellectual circles a matter of focusing on your speciality and not concerning yourself with other aspects of thinking, other aspects of perceiving. That began to change. And you can go back to the Enlightenment and see the Protestant Reformation, the shift in attitudes towards religious belief and other elements, political elements as well. underlying all of this. And I'm not going to go into the causes right now, but simply know that there was this distinct separation that grew over increasingly over 200 years through the 18th and the 19th century. By the end of the 19th century, scientific and humanist thinking began to move closer and closer. Began to move closer together. In 1894, Jules-Henri Poincaré began to publish on topology. At the turn of the century, Max Planck introduced his quanta theory of light, and shortly after that, Einstein, his theory of relativity. The sense of linearity of thinking, the Cartesian view of the world, was becoming undermined through a new physics, through a new way of perceiving, and that began to have impact on the humanities as well. Humanists began to see that the scientists, overtly, that the sciences had ways of thinking, ways of understanding that were very useful to them. In 1910, a man named Ernst Jones published a book called Hamlet and the Oedipus Complex, and he used Freudian thinking, Freudian science, to analyze literature, and it began a series of hyphenated literary critical projects that drew on not simply psychology, but history and biography and a range of science, including, over the last 30 years, chaos theory, as a way of expanding understanding of the universe. I'm sorry, expanding understanding of the topics under consideration. The segregation between the sciences and the humanities did not disappear immediately, and in fact, by the middle of the 20th century, it remained very strongly rooted. That was Einstein, Max Planck. Sorry, I told you I wasn't very good at this. It was still a dogmatic concept for many humanists and many sciences, the importance of keeping the two separate. In 1958, a man named C.P. Snow, who was a professor of chemistry and a novelist, and by all accounts, mediocre at both, gave a lecture at Cambridge, the Cambridge Reed Lecture, entitled Two Worlds, and it later was published as a book entitled Two Cultures and the Scientific Revolution. What Snow was saying was that it's important to keep things separate. His concern was that universities like Oxford and Cambridge were spending too much time, causing their students to spend too much time studying the humanities, and that this was impeding their progress as scientists, and he was strongly advocating for this separation. At the same time, the Cold War added a great deal of impetus to focusing, to specialization, to becoming more and more adept at a very specific, very specific topic or discipline. When the Russians launched Sputnik in the late, the first satellite in the late 1950s, there was a grave concern that there was a brain drain, a lag, that we weren't putting enough emphasis on this kind of education, that we were falling technologically behind other countries, and that it would have an impact, not simply intellectual, but economic and political on our country and others. Specialization became a way of responding to this, and it is even now remains a significant feature of education in the United States. Tracking began at a very early age, and I don't mean simply differentiating between subjects, English, math, general science, and the like, but rather putting students on certain paths towards learning about the world from a specific perspective, and not concerning oneself with other elements of thinking. The idea was the idea unspoken generally, but there nonetheless is that we can only learn so much. We can't waste our time with extraneous information. So we need to remain focused on just this very specific topic. Arthur Conan Doyle, in one of his Sherlock Holmes stories, lampoons this kind of thought when Watson is remembering, getting to know Sherlock Holmes, and being astounded to discover that Holmes didn't realize that the Earth orbited the Sun. And when he was told that, Holmes said, well, that's fine, but now that you've told me, I'm going to do my best to forget it. That has nothing to do with the process of detection, and it will only interfere with the analyses that are really important to me. So this has been an attitude that has been ingrained in the education system, that has taken on a legitimacy that I think needs to be addressed, not simply because it's the wrong way to approach learning, but because it's an inaccurate way. It doesn't understand the way we understand. And I think a clearer view comes from recognizing certain concepts. It's not enough to say that knowing does not begin to take place until one interprets data. That's an important point, but that doesn't sum up the process of acquiring knowledge. It's not sufficient to say that knowing occurs when we understand the assumptions behind all observations and all subsequent interpretations. That's important too, but that's simply a stage. What I think is most important, if we are going to understand the way we understand, is that we have to ask why one privileges certain assumptions over others. Why do I think it's important to report certain information and not other? Why is it important to study certain things and not other things? If I can understand that, then I understand the way I'm thinking, I understand the way I am situating, defining the world around me. And that to me is truly important and significant. Aristotle thought across a range of disciplines. 2,000 years later, Isaac Newton acknowledged the impact of those perceptions, when he said, if I've seen further, it's because I have stood on the shoulders of giants. Newton is reflecting the way of thinking, without necessarily giving it without specifically acknowledging, but reflecting this multiplicity as a strength in the process of knowing and of understanding. And it's this multiplicity that I think is important to reaffirm. Let me talk a little bit about some of the problems that occur when we don't show an awareness of a range of thought. In the early 70s, there was an experiment with a relatively small group of subjects conducted by a man named Roger W. Sperry at the California Institute of Technology. It was this group of people who were seeking treatment for epilepsy, 16 patients. And they agreed to, I have to read this because I could never remember the biological terms. The 16 patients agreed to let doctors cut the corpus callosum, which is the main nerve bundle that joins the two halves of the brain, and they found some relief from this rather extreme procedure. Those results were then extrapolated from first in a 1973 article in the New York Times Magazine, later on in Time, and finally in the Harvard Business Review and Psychology Today, all trumpeting the idea of the difference between the left brain and the right brain, the functions of the left brain and the functions of the right brain, as if we used them in a segregated fashion and did not rely on both to come to conclusions. It becomes an easy excuse for many of us to say, well, I can't balance my checkbook because I don't use that side of the brain very much. I don't like listening to Stravinsky's Rite of Spring because, well, that's not the side of the brain that gets its most exercise when I'm thinking about things. In fact, what it does, what the experiment did, much to Sperry's chagrin, was legitimize a reductiveness, a simplicity in thinking about thinking that wasn't intended at all. Problems from over-specialization can come not just from this dispensation. I don't have to think about science because I'm a humanist. I don't have to think about humanities because I'm a scientist. Problems from over-specialization can come from within the discipline. In 1974, a woman named Marian Tai of NYU published an article claiming to have discovered a new mathematical way to calculate a condition that was very specific to diabetes, and she was very excited about this discovery and thought it would be extremely useful. Within the next issue of the journal in which she published these results, in the next issue of the journal in which she published these results, a number of people wrote in and said, I'm sorry, that's a basic calculus procedure that anyone who's very familiar with mathematics will understand. And it was something that was a great embarrassment to her, but it underscored this point of what happens when I continue to specialize in my areas of study and ignore things that are even closely related to it. Sometimes the problem can come from the other extreme, from a lack of attention to the specificity, to the sophistication of related disciplines. There are people who are a little too quick to embrace what they think is an understanding of another discipline incorporated into their own, and with a superficial idea of it, they completely distort what they are seeing, what they are understanding. In 1993, there was a man named Alan Sokol, who was a professor of mathematics at University College London and a professor of physics at NYU. There he is. He submitted a paper to a journal called Social Text, and the paper was entitled Towards a Transformative Hermeneutics of Quantum Gravity. It was full of non sequiturs, of misapplications, of out-and-out errors, but it used the kind of jargon that certain cultural critics found very appealing, and the editor of Social Text, Andrew Ross, published it, accepted the article and published it. On the day it was published, Sokol published the second article in a journal called Lingua Franca, which is another social journal that commented on academic life, and he exposed the hoax. There was a great deal of weeping and gnashing of teeth among humanists, accusations of a lack of professionalism and violation of ethics, but the fact remains they didn't do their homework. They didn't pay sufficient attention to the disciplines that they were incorporating into their own, and they were too quick to privilege transgression over accuracy. What the consequences of these examples, and these are just a few of many, and I'm sure you could cite many more instances of misapplications and misconstructions, misprisions based on inadequate or narrow thinking. But when you have segregation, compartmentalization, or reduction, diminishing learning, while ignoring the facts, it presents a deeper problem in the education system. We're not acknowledging the way we think, and by not acknowledging the way we think, we are narrowing and reducing what we understand. I think that there certainly are ways of addressing the problem of correcting it, and most significantly is simply coming to a full awareness of the intellectual concepts that shape our perceptions. The field theory is a good example of that, or at least it provides dipping into it, like Andrew Ross in social text, although I hope with a little more accuracy. But dipping into it, I can come to what I think is a useful example by focusing on the idea that the observer always changes the environment. That there is no such thing as an objective observation, but that my presence in the process changes the dynamics, changes the environment, and reshapes what I'm seeing. If I understand that, I become aware of the complexity of the world around me. I become aware of the need to go beyond simply a mechanistic process of coming to a conclusion. And the humanities are just as guilty as the sciences. I don't want to seem as if I'm singling out one area or another. We all fall into patterns of thinking that begin as shortcuts and end as subversions of real thinking. And this is what I'm saying is that as long as we are aware of the complexities, we have a much greater chance of understanding what we're seeing and coming to a deeper conclusion. All this is working towards a proposal that I want to put forward here at FIU for a consortium of science and the humanities. I don't for a minute think that it's necessary, that a radical restructuring of curricula is necessary, but I think that we can do a great deal to make our disciplines more robust by educating ourselves and educating our students on the complementarity that exists. What I would like to do, what I would like to propose is a series of interactions between faculty and students that will open up their awareness to the way one area of thinking informs another, beginning at the high school level, with high school students visiting the FIU campus and shadowing an FIU faculty member, one semester a scientist and one semester a humanist, with the goal that by the end of this semester, that high school student would have a clearer understanding of simply one aspect of the profession that the faculty member whom he or she was shadowing pursues, whether it be what does it take to write, to what are the mechanics setting up a chemistry lab? What does it take to prepare an analysis of a literary text? How do these things, how are they put together? I would like to continue that process with undergraduates here at FIU, rather than alternating, selecting undergraduates from the science to shadow faculty in the humanities for a semester, selecting undergraduates in the humanities to do the same for sciences. The results would be the same, learning a particular skill. It would be on a more sophisticated level, but what is, I think, most significant is that it would make people aware, make us all aware that the existence of thinking beyond the boundaries delineated by our disciplines. I would like to want to continue that with graduate students as well, and also have a series of lectures, one in the fall and one in the spring, in which a scientist talks about the humanities and a humanist talks about the sciences. We've had several of these already. David Lee, in fact, gave a very good talk on flowers and combined the two, both from a botanical and an aesthetic perspective. But I would like to institutionalize this to begin a conversation about complementarity and to increase the awareness of not by asking anyone on campus to do anything more than we already do, but rather to understand what we are already doing and how that thinking is structured in a more complex way than perhaps we are always willing to acknowledge. From these projects, I hope to go on to expand to grants grants that will support interdisciplinary students, interdisciplinary thinking among our students, faculty research in the community, grants to support faculty research, linking scientists to humanist institutions like museums, galleries, and cinemas, and humanists to scientific enterprises, very much like Javier Cortados, who is an artist in residence here at FIU this year. Javier Cortados worked on sea level rise in Miami Beach. And I think finally a more universal awareness of the cooperation between the sciences and the humanities by the university themselves facilitating interdisciplinary studies. Those are the ideas that I have. I thank you for your patience in listening to them, and I welcome any comments or suggestions that you might care to make. Thank you. Yes.
When you say the way we think, are you referring to the new developments of brain science research?
No, I'm not. Yes and no. I am referring to the physiological element of the process of cognition, only to the degree that I'm arguing against the misapplication of the left brain, right brain concept. That the brain thinks in unison, and it just as the body works in unison to perform different tasks. Certain muscles, given the task, will be required to perform more, but the body it's all part of the unified movement of the body. But to me, what's more important is the recognition that we cannot think selectively, even when I'm doing something as abstract, perhaps, as a mathematical problem, or glossing lines of a sonnet by Shakespeare. I cannot exclude all my other experiences, and those experiences shape the way I come to an understanding. I'm not asking anyone to change the way they think about science or about the humanities, but to understand that how they think, how we all think about science and the humanities comes out of this amalgamation. That to me is what's most significant. Yes.
I'm going to bring up something that really shapes a lot the way we think from early levels and continues to the academic world, and that's academic textbooks. And most academic textbooks, I mean, I'll talk for my discipline, because you mentioned about this of a specialization issue. And what I have seen, is propagation of editions and books that they all are similar, right? I see very little innovation in terms of what you just described. And, frankly saying, sometimes a lot of missed opportunities. For example, just to give you an example, when I was in my physics class in secondary school, I learned a way of determining, the fields based on my right thumb. And then when I went to college, I used the same method to derive stereochemistry, for example, centers, much easier than my textbook did. And I haven't seen this being in every textbook uses the very same way. I mean, I see very little innovation in educational textbooks. I'm sure, but in secondary, it's even worse in high school or in middle school.
Mm-hmm.
So my question is, if our youth is already shaped the way they're thinking based on the fact that science is very disciplinary and humanities are far from each other and different, by the time we're doing something here, it's already too late. Don't you think?
You're exactly right. I think that I mentioned just in passing the way tracking begins in middle school, perhaps even earlier than middle school now, but where the emphasis is on one area or another, I think with fatal consequences. It's easier to manage instruction when I narrow the area of concern. When I say this is all you need to learn the goddamn Pythagorean theorem, and you don't need to know who Pythagoras was or any of the background. Just learn that a squared plus b squared equals c squared. I hope that's right. That's fine for if we want to produce nothing but mechanics. But your reference to physics is absolutely perfect, because physics is the I shouldn't say the most creative science, because that would imply that I have this deep understanding of all sciences, but physics is a tremendously creative discipline. It's a discipline, theoretical physics, where people will very openly say, I like the theory because it's a beautiful theory. I don't know if it actually works, but it had it had this tremendous beauty, and those who followed that impulse have led to some incredible discoveries in physics. But to go back to your point, it's got to begin in the schools, and that's what I meant when I introduced this idea of bringing high school students to campus. That's only the first step, and I've spoken with the vice president of engagement here at FIU. He's very excited about the idea. He thinks that high school principals would be, even if that comes about and it works, that's like throwing a deck chair off the Titanic. There's so much more that needs to be done, and it has to be revised at the most fundamental level. But the first thing that we can do in the university, and I say this more in terms of the humanities than the sciences, the first thing we can do is let go of our insularity. There's a great fear of other areas here at the university, and the great revelation that I had by being a STEM fellow and by coming to these deeper talks was that all of these problems that I think, and some of my colleagues in the humanities think are solely ours, because we don't get the attention, we don't get the resources that the sciences do, are replicated in the sciences. We all have the same kinds of struggles for resources, the same concerns about students, the same approach to knowing. And when we are able to acknowledge the similarities with one another, we're taking the first step. I mean, it sounds almost dismissively simplistic, but I think it is really an important step that we can make, simply to be aware of how much more we have in common than we have that is different. Because we're going to be teaching the high school teachers, who are then going to be teaching the students, and our attitude, our approach can begin to change things. So that's where I'm headed.
Yeah, to be more specific, have you thought about putting together with a scientist a truly innovative K-12 textbook? That's where I was going to.
I have not, but that's a terrific idea. And I think that's I think that's a great idea.
Because the textbooks are what straightjacketing our students. That's what
Right.
they need from a very early age.
Well, not only do they reach students, but they're very attractive to the people who write them. It's a lucrative thing to do. So I firmly believe that no one behaves altruistic. We behave the way we do because there is some sort of reward, intellectual, material, spiritual, whatever. But that's a terrific idea. And I think it would sell with publishers because it would be a different approach.
As I was listening, I was thinking about general education, how at FIU, for example, students are asked to take courses, from a variety of disciplines. And I wonder if I think we know the purpose of that, but I'm not sure if we're accomplishing it. And one piece that could be missing is an explicit focus on the ways of thinking in, making it explicit to students, the ways that in a discipline we think, or we, for example, use evidence, or what kind of evidence counts as persuasive or whatever. I think that sometimes we don't make ways of thinking explicit, and that we can frame, especially general education, more that way.
I think that's a very good point, and I think you're being too generous to most of us here at FIU. I don't think we sufficiently value the core. In almost any department that one can go to, you'll find an impetus that's set for dropping core requirements so we can expand requirements for the major. Because what's really important are the things that we're teaching in our discipline, and the rest of that crap are things they have to go through until they get to us. And the faster we can remove these impediments, the faster they come to us, the more we can teach them. And that's I think a very mistaken view. It's understandable because economics is at the bottom of just about every decision that occurs at the university, overtly at the administrative level, but there nonetheless as a subtext for departmental decisions. If we don't have enough majors, the budget goes down. If the budget goes down, the way we function changes. Life isn't as pleasant as it is right now. So I think what we need to do, what needs to be done is a global change across the university that says we're going to measure things differently. We're going to see achievement and accomplishment in a different fashion. That's not going to happen, at least not in the short term. But that underscores what absolutely needs to occur. But the things that we can control are ways of approaching our own discipline, topics within our discipline that welcome the diversity that occurs at the core, rather than treat them as impediments.
I'm going to go back to Till 12. And I wanted to ask you, do you support or do you think is beneficial to the students to actually have a change on our K-12 curriculum to be more core-oriented without much electives and choice, similar to Europe, for example? Or do you support the way currently things are, but in many states, for example, you can finish high school without any chemistry or without any physics even, I'm not so sure about that, but so what do you think about this? Do you think we should go back to core, the same way as the European system?
By core, you mean the major?
What I mean on the K-12, okay, the students don't have that much choice of what class they take, so they have to take 3 years.
Okay.
3 years of physics, 2 years of chemistry, 6 years of whatever, calculus or math, that much of English, and only have very little choice. In Europe, it's like that. Right. In the United States, we have a different system where the students can, finish high school, not take any chemistry. I'm not in Florida anymore, but I think in other states probably it's true.
I don't think it matters. I don't think that's where the problem lies. Whether it is an apparently diverse system or an apparently rigid system, I think that it's much more specific. The issue that I'm speaking of is much more specific to the perspective of instruction. If you've I'm trying to remember the discovery that Aristotle made for the way an octopus fertilizes, the way one octopus fertilizes another, and it's an appendage that moves sperm into the other octopus. It wasn't until, and Aristotle did this simply by observing sea life around the coast of Greece. It wasn't until Cuvier in the 19th century that was validated, that people began to accept it. But Aristotle thought in a way that blended. When he spoke of natural philosophy, he was speaking of science, but science in the context of the metaphysical world, and he was able to make these discoveries. If we can come back to the idea that physics and metaphysics are part of the way we understand the world, then it doesn't matter if I'm teaching simply physics or if I'm teaching a course on life in the physical world that goes on. That seems to take a much broader perspective, but in reality, it depends upon those fundamental assumptions. So your question is well put, but for me, the problem is even deeper than how we structure the curriculum. I'm sorry, you had a question.
And, well, I kind of wanted to piggyback on this idea of the way that the core curriculum is perceived, and this is a cultural issue and a political issue, and this great framing of education as being for workforce production versus for intellectual growth, and that would eventually do some workforce production, but this very straight line, and in my surveys of the students, you really hear this reflected back, this discourse of why do I have to waste my time taking this core curriculum? Why do I have to pay for all these classes that are useless to me because I'm going to be this or that or the other thing, and they don't apply? And so it's really a set of ideas that I think all of us have an opportunity to address and to counter, that that these many things that you learn are useful and that are not just wastes of your time and wastes of your money, but they are, I think, all of us here value the diverse parts of our education that we receive, but I think the generation of students who are now in the university have been brought up in a culturally different moment where those ideas about education have really changed and really given them the impression that all the rest of this is a waste of their time.
think you put that in a terrific way. To me, one of the problems, a significant problem of university life, and it's a problem that we, all of us, contribute to, is this movement towards a trade school approach to education. And I'm not sneering at trade school, but I'm saying a university and a trade school should be. They are very different in their concepts, and they should remain so. Yet one of the first things that we tell our majors is, this is the kind of job you'll be able to get when you graduate with a degree in ... And this is about how much you can expect to earn. In some respects, students need to know, because they are being crushed by student loans right now. And to leave the university without some sense of how am I going to get out from under this debt is an unthinkable thought for them, and it would be irresponsible for us simply to say, don't worry about it. The student loan system will implode, and then you won't have to pay anything back. Instead, I think what we need to focus on is the idea that we are an intellectual community, and that we achieve a tremendous amount for each of our students over 4 years, and that our students change dramatically from the time they come here to the time they leave. And our greatest achievement is they can think. They know how to use their brains, and they have a sense of the specialization. They've learned how to think as a chemist, or as a biologist, or as a historian, or a literary critic. But what's even more significant is that they can use their mind, and goddamn it, they won't starve to death. I mean, it's hard to say that to them. Don't worry about it. You'll find work, because they're nervous and need greater specificity. But if we believe in the university, I think that's a fair thing to say. If they want to be trained in a professional capacity, they can go to a graduate school or go to a professional school and receive enhanced training. But when they leave FIU or any other university as an undergraduate, they know how to think, except for the ones who plagiarize their way through school. But the ones who applied themselves, we've done an awful lot already, and we don't need to apologize for what we've done.
I think the complementarity could benefit from an emphasis on critical thinking, which is kind of piggyback slightly on what you're talking about.
Yeah.
Because traditionally, critical thinking has been the domain of the humanities, of English, of these disciplines. But really, it doesn't matter how genius of a scientist you are, or whatever your field is, if you don't have the critical thinking component. And what we're seeing now out, in the outside world, in the employer feedback that we're getting is that people do not have the critical thinking capacity now, as much as the employers would like them to have. So if they could combine their specialties along with the critical thinking component, then they would be more employable, for one thing, let alone to be able to think.
I think you're right. I agree with you, and I think that some of our students graduate with a greater facility for critical thinking than others. Within our disciplines, perhaps we have a tendency to see that critical thinking, rather than a trait that's shared across the disciplines, is varied from one to another, and it's easy. That's an easy perspective to fall into, because we think in a sophisticated way, and we focus on very specific problems, and we try to keep the white noise down. Don't distract me with other things. I'm trying to solve this problem. I'm trying to come to a clearer understanding of it. But at the heart are fundamental ways of seeing the world, a fundamental approach to critical thinking that is shared no matter what the discipline is. And one of the things I was most concerned with in presenting this talk in addition to the PowerPoint demonstration, but I didn't want to seem as if I was antagonistic towards the sciences or towards the humanities or towards any discipline. I think that's a real mistake. If anything, I've become much more respectful across disciplines by being part of this DEBRA group, part of the STEM Institute, because I see the connections, I see the importance of what each, and the complementarity of what we're doing. So it's easy to fall back into specificity because that's where our research lies. But for the most sophisticated research that we can do, if we can sustain that idea of multiplicity, of different perspectives, in the end, the findings will be more gratifying.
I just want to recommend an article called Writing as Situated Thinking in General Education by Yvonne Merrill. Reading this article really changed my conception of how I should teach or how one should teach, especially in general education. And it's focused on how the ways we think in different disciplines are different, and they're socially constructed and they're task specific. And Yvonne Merrill facilitated a discussion among faculty from different disciplines about thinking. And I think that sort of conversation, like what we're having now, is really helpful because whenever we're within our own disciplines, we take a lot of things for granted that our students may not take for granted, or we don't want them to take for granted. And so I guess I'm just going back to the idea of thinking and thinking about thinking, which is metacognition, more explicit in our instruction so that students have a broadened perspective.
Can you send the link to Rocio?
Sure. Yeah,
Great, thank you.
for sure.
I'm going to go back to what you mentioned about this pressure the students have to, get a job when they graduate. And there is, our governor has clearly stated he wants the universities to provide, degrees that will give students a job with very little money and all this. Now, there is a dilemma, as you said, how do we invest in students' time? Specializing so they can get jobs, or giving them a holistic education they can really think of what broadly. And to me, this is a problem that is impossible to solve. Impossible unless we really address it at early levels before the students come here. So that's where we can have really a big impact. That's why I keep going back to K-12, because I have seen students come here on the first year, okay? They want to do sciences and they don't know basic calculus, or they don't know how to write. They don't want to write any exam that is not multiple choice. And this, it means that the high school doesn't do its job. Now, if the high school did its job, all right, did exactly what you said, gave them an education which is giving them an all-around core of science and humanities together, so the students are prepared to come and critically think here, there wouldn't be a problem because we could offer a specialized curriculum and they would already be ready for it. So that's why I think it's important to go and address this before the students even come here. Coming here, it's way too late.
No,
It's way
well,
too late.
yes and no. I agree with you that the heart of the problem lies in the primary grade.
And there is so much
the way
conservatism
education
there.
is structured from the very
Mhm.
beginning. At the same time, I think that we can do a lot for the students if we can underscore the value of what they get here at FIU, the value of using their mind. None of us want to be in the situation of saying, if you do this, you'll get this kind of job. And then 5 years later, run into the student who was pushing a shopping cart down Flagler Avenue and said, what the hell did you tell me? I did it and didn't get the job. Well, the economy changed, the emphasis changed. I think that we would have a more effective educational system following the blueprint that you're alluding to, beginning from the earliest grades and making students aware of this complementarity. Failing that, what can we do? What can I do tomorrow at FIU? Tomorrow I can talk to my students about the process of thinking and readily acknowledge that when I teach, when we read Virginia Woolf's Mrs. Dalloway, and we talk about what that means and how that can be interpreted, that isn't a piece of information that's set in stone. That's an exercise in using their mind, and it's not an exercise that relates only to this one novel by Virginia Woolf and has no application anywhere else. It is a demonstration of what highly sensitive, carefully chosen procedures can produce, of what a well-trained mind can come up with in a specific instance, but using a pattern of thought that is transferable to almost any other form. It would be daunting for me to become a biology major right now and start as a freshman and get over that terror that I have, the left brain, right brain lie that I told to myself all these years to absolve myself from trying to understand anything about science. It would be terrifying, but I could do it. If I put my mind to it, if I was determined to think in a critical way, to understand the material in front of me, because I've been trained to use my mind. Any of us could do it. One of the things there are two things that someone will almost always say to you if you're on a plane and they say, "What do you do for a living?" "Oh, I teach English at FIU, at Florida International University." They will either say, "I always hated English in high school," or "Now I guess I have to watch the way I speak, so my grammar is correct." There is that kind of reductive thinking is what we have to undermine. That sense that there is, that we are learning a set of skills the way a bricklayer, the difference between a bricklayer and someone who builds the cathedral. The bricklayer has a tremendous skill and can align these bricks and make sure they're straight and do the corners properly and mix the mortar in whatever way. The person who builds the cathedral understands that process, but understands beyond that, understands how the different elements, understands how to achieve the beauty of the cathedral through the material construction of the bricks and the mortar, and I think that's the gap that we need to bridge. We are teaching specific skills, but we have to make students aware that the skills that we teach them are not in and of themselves enough. They're perhaps not even the most important thing, but rather
In
the
science,
way
they're outdated within a few years.
Right.
Specific skills, you have to retrain constantly.
Exactly. No one knows that better than engineers, who are obsolete at 10 years after they graduate. They better damn well go into management, or they'll be out of a job.
Yeah, like exactly what Jean was saying is what I was thinking about too. In May, we had a workshop in our writing program, and it was like the Gateways workshop, and we were talking about what sort of literacies are important for students in the 21st century. And one of the ones that we talked about was learning, unlearning, and relearning as a literacy that students need. And there's a quote from Alvin Toffler: "The illiterate of the 21st century are not those who cannot read and write, but those who cannot learn, unlearn, and relearn." And he was talking about the skills that students need in a knowledge economy. But the reason that I'm bringing this up is because it's kind of in response to the idea that, you know, students are so set from their K-12 experience that it's difficult to shift their ways of thinking. But I think that we can do it through a process of unlearning and relearning. And it is unfortunate that, you know, time is taken up with unlearning, but I think that maybe we can accept that it's part of the process sometimes.
Sure, it can happen, but would it be easier if we transformed the secondary education here, rather than trying to solve the problem much later? That's the thing, because there is so much, I mean, I don't know if it's true, you probably know that better than me. Is it true that the textbooks, for example, in the whole United States in K-12 in public schools are decided by, you know, a few people in Texas, is that right? Or something like that? And then they adopt the textbooks everywhere, or Texas, New York, and another state?
Because
Is it
the
true?
textbooks
Size of the
are
market.
established
Yeah.
statewide in Texas. Texas is such a large state that they can drive publishing, because
Yeah.
Texas says the textbooks have to be like this, so they're not going to write one textbook for Texas and one for the rest of the country. And so that's how, I think that's how it works.
Yeah, I heard that on NPR, so it wasn't something that I saw or something, but.
Yes. I'm sorry.
Just a comment. I think in order for our students to really recognize this complementarity, we really need to start from our faculty. Because in a lot of cases, I think the scientific way of thinking is actually privileged over the humanistic way of thinking. Just to think about it, how many science faculty would really value the humanistic way of thinking, and how many humanity faculty would actually stretch themselves to the scientific way of thinking. So I think opportunities like this, or opportunities to kind of expose faculty to the successful cases of interaction or integration of scientific and humanistic way of thinking would be very helpful.
And I think what you're saying is right on the mark. And I hope I didn't give the impression that what I'm advocating is a radical reconstruction of the way any discipline is approached, the way topics, questions in any discipline is approached. That's not what I meant at all, but rather a greater sense of the application of humanities for a scientist could be, should be, along the level of, why do I make the choices that I make towards research? Why? And the short answer might be, well, because my dissertation director told me to do this, and this set me on a course of life, and this is what I do from now on, whether I like it or not, because of some fluke at the end of my graduate career. Nonetheless, when I'm, as a scientist, when I'm looking at a particular problem, when I am trying to understand what I'm observing, my understanding is not mechanical. It's not strictly according to a formula. It is informed by scientific learning. It's informed by everything that I've studied in that discipline. But I think in a complex way. I think in a way that's influenced not simply by the information within my discipline, but by experiences that traverse my entire life. If I understand that, then I have a clearer idea of how I'm understanding, and what I see then becomes richer, because I have a fuller sense of what exactly I'm seeing. The same is true of the humanities. If for a humanist is not aware of how the sciences has shaped his or her sense of explicating a poem by William Butler Yeats, then that person isn't paying attention, and that person is making a reductive, a simplistic conclusion about what's in front of it. So I don't advocate changing the fundamental analytical approaches that are followed in any discipline, because especially at a sophisticated level, those approaches are structured in the way they are for a particular reason, because they produced success before and will continue to produce success. But I think that the deeper understanding of what is being seen comes out of a broader understanding of all the forces that inform my perception, and that's what I'm getting.
Thank you so much, Michael.